So in this session, we'll discuss the free fall motion. What is the meaning of a free fall motion when object is dropped from certain height, even it is a lighter object or if it's a heavy object. Example, I have 2 kilogram object and we have 5 kilogram object. Both are dropped from the same height, from the same level. So what will be the force which is acting, like this is a ground or the surface. So the ground is the force of a gravity of the earth which is acting on these objects which are having mass. What about the weight of 2 kilogram object? The weight of 2 kilogram will be equal to 20 Newton because the gravity of the earth is 10, so weight is mass multiplied by gravity. What about the weight of 5 kilogram object? It will be 5 multiplied by 10, that is equal to 50 Newton. So because these objects have weight or they experience the gravitational force, so when these objects experience the gravitational force of the earth, they tend to move towards the surface of the earth. And what we call this motion, we call this motion as a free fall motion. So basically, what is the definition of a free fall motion? It means when objects fall freely under the effect of the gravity or due to their weight, we call that as a free fall motion. If we try to calculate the acceleration of the object, what about acceleration of object A? So if we try to calculate the acceleration, we have the formula F is equals to ma. So force is equals to 20. The mass is 2 and we are finding acceleration. So this 2 is multiplied, other side it will be divided. So 20 divided by 2, that will be the acceleration, which is 10 meter per second square. So object A is having acceleration of 10 meter per second square. What about acceleration of object B? We have the formula F is equals to ma. The force which is acting on this object, that is the weight. M is the mass, which is 5, and A is the acceleration. 5 is multiplied, other side it will be divided. So 50 divided by 5, what is the acceleration? Again, it will be 10 meter per second square. So whenever objects are falling in the absence of air resistance, our assumption for this motion that there is no air resistance, like there is no air to stop the moving object or to try to slow down the moving object or try to reduce the acceleration. So when there is no air resistance, even if it's a lighter object or it's a heavy object, both objects will fall with the same acceleration, and this acceleration is known as acceleration due to gravity. And that is denoted by letter G. That's why we say gravity is 10 or acceleration due to gravity is also 10. So the concept of a free fall motion, when objects experiencing the force of gravity, they tend to move towards the surface of the earth, and they all have the same acceleration, that is 10 meter per second square on the surface of earth. So when an object is released near the surface of the earth, it will fall under the influence of a gravity, and we call that as a free fall motion. The acceleration of a free fall or acceleration due to gravity is denoted by letter G, and it is on earth, different planets it's having a different value, but on earth it is 10 meter per second square, and this is only true in the absence of air resistance. If air resistance is there, the acceleration will not be 10, it will be less than 10. So what does it mean? The acceleration is 10. Example, if we have an object initially at rest, so its speed is 0 meter per second. When we drop after 1 second, because we know for falling objects, objects which are falling under the influence of the gravity, they all have the same acceleration and they all should have the acceleration as 10 meter per second square. So what does it mean? It means every second the speed should change by 10. So if originally it is 0, after 1 second, what will be the speed? The speed will be 10. Then after 2 seconds, what will be the speed? The speed will be 20. Then after 3 seconds, if it does not hit the ground, after 3 seconds, the speed will be 30 meter per second. So every second for falling object, speed will change by 10, and we call that as acceleration due to gravity. It does not depend on the size of the object, even the object is lighter or the object is heavy. They all have the same acceleration. So if I drop, say, a 1 kilogram object and I drop a 5 kilogram object, both will have the same acceleration, because acceleration due to gravity does not depend on the mass of an object. It's a fixed value. So after 1 second, the speed of this 5 kilogram object will be 10. After 2 seconds, it will be 20. After 3 seconds, it will be 30. So every second, the speed will change by the same value. That's why if we drop two objects, one is lighter and one is heavier, what will happen? Both will hit the ground at the same time, because they have constant or same acceleration, which is 10 meter per second square. Is it clear, the concept of acceleration due to gravity? Acceleration of a free fall, when objects are falling freely under the influence of a gravity, they all have the same change in the speed, or they all have the same acceleration. So it is independent of the mass of an object. So if I have three different objects, I have 1 kilogram object, I have 5 kilogram object, and I have 10 kilogram object. Yeah, even the masses are different. Look, when I try to work out the acceleration, say I have 1 kilogram object, I have 5 kilogram object, and I have 10 kilogram object. That's the mass. What about the weight? For 1 kilogram, the weight is equals to 10 Newton, because weight is mass multiplied by gravity. What about 5 kilogram object? The weight will be 50 Newtons. And what about 10 kilogram object? The weight will be 100 Newton. So when I calculate the acceleration, we know F is equals to ma, the formula to calculate the acceleration. If we know the change in speed, we can use that formula. Otherwise, if the force and the mass is given, then acceleration is force divided by mass. So what is a force acting on 1 kilogram object? That is its weight 10, and divided by the mass. So acceleration will be equal to force divided by mass. So force is 10, the mass is 1. So the acceleration of this object A will be 10 meter per second square. When I calculate the acceleration of object B, that is also force divided by mass. So force is 50 and the mass is 5. So 50 divided by 5, that's also equal to 10 meter per second square. And when I calculate for C, so force is 100 and the mass is 10. So acceleration will be 10 meter per second square. So all the objects A, B, C, you can clearly see they have different masses, they have different weights, but what is common for all of them, they have the same acceleration. So in the absence of air resistance, objects have the same acceleration. So when they fall towards the surface of the earth, they will take the same time to hit the surface. And we call that as acceleration due to gravity. But the condition in the absence of air resistance. Example, if you drop a feather and a lead ball, they both have different masses, they have different weight, but in the absence of air resistance, without air resistance, when these objects will fall, they will have the same acceleration, so they will take the same time to hit the bottom of this container. Example, in this video you can see we have a ball and a feather, both are dropped, and you can clear in the absence of air resistance is not there, so you can clearly see that both are falling with the same acceleration, same change in speed. So both will hit the ground at the same time. And what is the reason for that? Because the acceleration of the ball is same as the acceleration of the feather. So when they will hit the ground or hit the surface, they will take same time to hit the surface. Is it clear, this concept of acceleration of a free fall? But what is the condition? The condition that there should be no air resistance. Air resistance should not oppose the motion. If there is air resistance, then acceleration will be different. But if there is no air resistance, acceleration is always 10 or a constant value on Earth. When we sketch a graph to show this result, so if we want to sketch a graph for falling objects without air resistance, so if the object is falling without air resistance and we want to sketch a velocity time graph, on x-axis we have time, so that is, this one is 0, 1, 2, 3, 4 and 5, and example 10, 20, 30, 40 and 50. So this object is dropped, say the time initially is 0 and it is at rest, so 0 meter per second. So when we plot the graph, the first point, it will be 0, 0, origin. Then after 1 second, after 1 second of a fall, because it is having an acceleration on Earth, it is having acceleration of a 10. So after 1 second, speed will change by 10. Originally it was 0. So speed changes by 10. So at 1 second, the speed is equals to 10. Then after 2 seconds, so when time is equals to 2 seconds, the speed will again change by 10. So speed will be 20 meter per second. So after 2 seconds, it will be 20. After 3 seconds of the fall, it will be 30. Then after 4 seconds, it will be 40. After 5 seconds, it will be 50. So when we join these points, what we will get for a speed time graph or a velocity time graph, it will be a straight line. So whenever it's a straight line, what does it mean? It means it is having a constant acceleration, and that acceleration for a falling object on the surface of the earth is 10. So whenever object fall, it will always have a constant acceleration, but the condition is without air resistance. If you want to sketch a graph for acceleration and time, so because for falling objects acceleration is same or constant, so on earth it will be a horizontal line and the value of the acceleration will be 10. So after 1 second it will be 10, after 2 seconds 10, after 3 seconds 10, after 4 seconds 10. That's why it will be a horizontal line for acceleration time graph. This is the acceleration and time graph, and the previous one was a speed time graph or velocity time graph. Is it clear? The graph for falling objects without air resistance. Any doubt till this point? But what will happen if there is a air resistance? If there is a air resistance, the acceleration of the object will decrease. It will not be constant. The acceleration will change. The difference between the graphs, this is a speed time graph. The speed time graph, so when time is equals to 0, speed was 0. When time is equals to 1, speed is 10. When time is equals to 2, speed is 20. Time is equals to 3, speed is 30. What about acceleration? The term acceleration means change in the velocity. Divide by time interval. So what is the acceleration here? That is 10. What about acceleration from 1 second to 2 seconds? That is also 10. What about acceleration from 3 seconds, 2 seconds to 3 seconds? So that is also 10. So if we plot acceleration and time graph, so every second the acceleration will be 10. So when we join these points, the acceleration time graph, it will be a horizontal line, whereas speed time graph or velocity time graph, it will be a straight line with a constant gradient or slope. So this is a graph when object is falling without air resistance. But what will happen if there is air resistance acting on it? So if object is falling in the presence of air resistance is acting on the object. Now the acceleration will not be same. The acceleration will decrease and it will be 0. Because what happened when the object is falling, its speed increases, so the air resistance will also increase. So if object is falling in the presence of air resistance is acting, and as the speed increases, the air resistance will also increase. Example, here's an object, and I say its mass is equals to 2 kilogram. So what will be the weight of this object? It is dropped from rest, so its speed is 0. What about if mass is 2 kilogram? What will be the weight on earth? The mass of object is 2 kg. What about the weight on earth? That's equal to 20 Newton. That's good. So the weight will be equal to 20 newtons. Now, what is the acceleration? Initially, what is the acceleration? because acceleration is force divided by mass. So force is 20 and the mass is 2, so 20 divided by 2. Initially acceleration is 10 meter per second square. As this object is falling, initially it will have a constant acceleration initially, but as the acceleration is there, speed will change, speed will increase. As the speed will increase, what will happen? The air resistance will also increase. And what is the direction of the air resistance? Air resistance will always try to stop the object, to oppose the motion. So if object is falling down, if object is moving down, the air resistance will act upward. So if the weight of the object is 20, but because air resistance is there which will try to oppose, so example, the air resistance is 10 Newton. So what is the force acting on this object now? What about the force acting on the object when the air resistance is 10? Weight is 20 and air resistance is upward 10. What about the force acting on the object? The resultant force. 20 Newton is the weight acting down and air resistance is acting upward. So the force, resultant force will be 10. And same way, if I say the air resistance, yeah, 10 Newton is a total resultant force is 10. So when we use this formula, we always substitute the resultant force. So resultant force is 10 and the mass is 2. So 10 divided by 2. Now what is the acceleration? Acceleration is 5 meter per second square. But because the object is accelerating, so its speed will increase until the weight which is 20 Newton acting downward balances with a force of air resistance 20 Newton upward. So if air resistance is 20 up and the weight is 20 down, what is the resultant force on the object? Here the resultant force was 10. Here the resultant force was 20. And what about the resultant force here? 20 Newton, air resistance is upward and weight is acting downward. So resultant force will be 0. And when resultant force is 0, so 0 divided by the mass which is 2 kilogram. So 0 divided by 2, what we'll get? We'll get 0 meter per second square. So when no resultant force, there will be no acceleration. So when there is no acceleration, no change in speed, the object will move with a constant speed, which is known as the terminal speed. So when we sketch a graph for a speed time graph for object falling with air resistance, so first it will be a straight line. Initially it is a straight line, means constant acceleration, this part. Then because air resistance is increasing, if air resistance increase, the resultant force is decreasing. That's why the acceleration will decrease. And once the resultant force is 0, so it will have no acceleration. The object will move with a constant speed, and this constant speed is having a particular name which is known as the terminal velocity. So terminal velocity means the constant speed when the object is not changing the speed or it does not have any acceleration. So at this point in the beginning, the acceleration is constant. At this point, the acceleration is decreasing. And here, the acceleration is 0, which shows that object weight balances with the air resistance. That's why the acceleration is 0 and it will fall with a terminal speed or a terminal velocity. So this is what happened for object falling under the influence of air resistance. So if there is air resistance acceleration initially it is constant, then decrease, then 0. But if there is no air resistance, then the acceleration will always be constant. Is it clear, this graph? So example, say a paratrooper is there or a parachutist is there. He jumps from the aircraft, he jumps from the plane. So consider a parachutist, he jumps from the aircraft. So his weight is acting downward. If I say his weight is 600 Newton, and there is initially, because the moment he jumped, there is no air resistance. So if there is no air resistance in the beginning, the moment just he jumped, initially there is no air resistance. So acceleration will be 10 meter per second square. So when the parachutist jumps from the aircraft, his speed increases due to the weight of his body or the gravitational force. Now as his speed increases, the air resistance will also increase. So the weight will not change. The weight is 600 Newton. Example, air resistance is 200 Newton. What is the resultant force acting on this parachutist? What is the resultant force acting on this parachutist? That is 400 Newton. So originally the force was only 600, but now the force is 400. So if the force decrease, what happened to acceleration? It will increase or decrease. Originally the force was 600, now the force is 400. So what happened to his acceleration? It will decrease, because if the force decreases, the acceleration will also decrease. So as his speed increases, the air resistance will also increase in opposite direction, and once his weight, which is 600 Newton, balances with the air resistance, which is 600, so the force on him is 0. If the force is 0, the acceleration will also be 0 meter per second square, and this parachutist will move with a constant speed. And what we call that as a terminal speed or terminal velocity. Is it clear till this point? Anyone having a doubt or a question? So this is what happened. He did not open the parachute. That's why you will find, like, the paratroopers, they can also perform or form or make different formations when they're falling through the air without opening a parachute, because they adjusted the air resistance with the weight. So they all have the same terminal speed and they can perform different formations. So this is, here the resultant force is downward, and 0 resultant force. Now when he opens the parachute, his weight is acting downward, which is 600 Newton, but now he opens the parachute. So the moment he opens the parachute, what will happen? His weight is not changing, that's 600. But air resistance, as because parachute will have a large surface area, so it will have a large air resistance. So example, air resistance will be 1000 Newton. So what is the resultant force here? A 1000 Newton air resistance, and the weight is 600. So resultant, yeah, that's good. The minus 400 Newton is the resultant force. What is the meaning of minus 400? It means the resultant force is upward. So resultant force is upward and the parachutist is moving down. This is the direction of the motion. So what is the effect of this? That due to the large air resistance, there is more upward force than the downward force. So the object will slow down. So this parachutist will slow down or he will decelerate. And as he decelerates, speed decreases. So when the speed decreases, the air resistance again decreases. So air resistance again balanced with the weight. So when air resistance balanced with the weight, again there is no resultant force and he will move with a constant speed again. So there are two times he's moving at a constant speed. One is without opening a parachute and one is after opening a parachute. But what is the advantage? That using a parachute, because the moment he opened the parachute, he will decelerate or slow down, so his speed will decrease. As he land on the ground, he will land at a smaller value of a speed, or at a lower speed. That's why it will not have greater impact on his body. Otherwise, if he is not able to open a parachute and he is falling with a terminal speed, but this terminal speed will be higher, so it will be a fatal, it can cause injury. But when opening a parachute, when the moment he opened the parachute, he slow down and again reaches the terminal velocity, so it will not hurt the parachutist. So that's the advantage of using a parachute. If we sketch the graph for these five motions, the first one, when the parachutist did not open the parachute initially, like the first three pictures, I say this is 1, 2 and 3. So initially the acceleration is 10, constant acceleration. Acceleration decrease, and here the acceleration will be 0. So how we represent these motion for 1, 2 and 3? So this is what happened. Constant acceleration, because that's a straight line. That's a picture 1. Then picture 2, because air resistance is increasing, so acceleration is decreasing. And then the picture 3, acceleration is 0. He is moving at a constant speed. Is it clear till this point? The first three pictures, explanation 1, 2 and 3. Then what happened? The moment he opened the parachute, so the moment he opened the parachute, this is picture 4. So because there is more upward force than downward force, so he will decelerate. Decelerate means the speed will decrease. So how we can represent a decrease in the speed? So this is when you open the parachute, his speed is decreasing. And once, again the fifth picture, the last picture, once the air resistance balanced with the weight, why the air resistance here is higher than this point? Because he was moving at a higher speed, that's why the air resistance is higher. But once the speed decreases, the air resistance will also decrease and it matches with the weight again, and he will move with a constant terminal speed or a lower terminal speed. Is it clear? This graph, the speed time graph for a parachutist falling freely? Any doubts in this part? Now some questions related to this. A parachutist is falling through air at a terminal velocity. Terminal velocity means constant velocity. So if he is falling at a constant velocity, so what is the condition for terminal velocity? As you can see in picture 3, he is moving at a terminal velocity with no acceleration. The term terminal velocity means constant velocity where the acceleration is 0. So whenever the object is moving with a terminal velocity, the resultant force should be 0, or we can say acceleration should be 0, or air resistance balances with the weight. And same thing happened for the last picture as well, that air resistance balances with the weight and he's moving at a terminal speed. So now the question is, which statement about the parachutist is correct? You can use a screen annotation or a chat if you want to answer. What could be the right answer for this? Every force acting on the parachute equal to 0? No, that's wrong. Not because there is a weight acting, air resistance is also acting. But the resultant force which is acting on the parachutist is equal to 0, and when resultant is 0, the acceleration will also be 0. And when acceleration is 0, the object will move at a constant speed known as the terminal speed. Is it clear, this part? The terminal speed for or a constant speed? Any doubt in this? Whenever the question is, the parachutist is falling through air at a terminal speed. What is the meaning of terminal speed? The term terminal speed means constant speed. And when speed is constant, there should be no acceleration. And when there is no acceleration, there should be no resultant force. So which statement is correct? The resultant force acting on the parachute is equal to 0. The weight is there, weight is acting downward, air resistance is acting upward, but the result of the weight, like example, if weight is 600, air resistance is also 600, so result of weight and air resistance is 0. And if resultant force is 0, what about acceleration? The acceleration will be 0 as well. That's why C is the right answer.